Hi everyone, let us solve today's problem of the day, that is letters collection. Let us go through the problem first. The postmaster wants to write a program to answer the queries regarding letter collection in a city. Okay, so a city is represented as a matrix of size n into m. Each cell represents a house and contains letters which are denoted by a number in the cell. Okay, and the program should answer q queries which are of the following types. Query 1, that is I and j, to sum all the letters which are at one hop distance from the cell I comma j in any direction. Okay, and query 2 is to sum all the letters which are at two hop distance from this cell I and j in any direction. All right, so the queries are given in 2D matrix queries. In one hop distance, postmaster can go to any of these directions. Okay, so that is the eight direction. So what is the question stating is that we have a matrix of integers, right? And we are given some certain queries in a 2D matrix itself. Okay, so in that we have two types of queries, that is query 1 and query 2. So what is query 1 is to sum all the uh, numbers, sum of all the letters which are at one hop distance, okay, from that I and j. And query 2 is to sum all the letters which are at two hop distance. So we need to return the sum of these numbers basically, and we need to individually answer both the queries. Okay, so for example, in this the first test case, we have a matrix and we have two queries in which we first query is 1 and 0 and 1. So this represents the row and the column, basically I and j, the position of that particular row and column, and we need to return from that particular row and column one hop distance to all the letters. Okay, for example, we have 2, then in that case we need to return from 0 comma 1. Where is 0 comma 1? That is this one, right? 0 comma 0, 0 comma 1. So from here we need to return sum of all the numbers at 2 hop. Okay, so from here what are all the numbers till which I can reach from 2 hop is all these numbers. Okay, 9, 1, 3, 4, 8 and 4 again. Okay, so we'll be discussing this and we get these two queries output as 22 and 29. Okay, so what exactly are these hops? Let us understand it through this example. Let us say that we have this matrix, right? And this is its index values. For example, 1 is at 0 comma 0, then we have 0 comma 1, 0 comma 2. Okay, so let us say we are highlighting a number 3 which is at 2 comma 2, right? This is the index value. So what if I take one hop from this particular I and jth integer or this particular position? So one hop will cover all the values, that is 6, 7, 8, right? Then I have 4, 4, 3, 2 and 1, 6. Basically one hop means from this particular index I am going with one hop or one position, right? So that will be one position towards upward, downward, left, right, and also including its diagonal. So how many elements am I having? I will be having 8 elements, right? So if I look at its index value, from 3 I can visit 6. Okay, that is 1 comma 1. From 3 I can also visit 7 in one hop, that is 1 comma 2. So if you look at look at their indexes, 1 comma 1, from 2 comma 2 we are going to 1 comma 1, right? So that is from I and j, from I and j we are subtracting 1 from both I and j. Okay, so that is I minus 1 and j minus 1. So from 2 comma 2 how can we get 1 comma 2? That is I minus 1 comma j. So these are the mappings of all the index values, right, in one hop. So this will be the mappings of both the index value. Basically minus 1 comma minus 1 is the mapping of this element. How can we reach from 2 comma 2 to 1 comma 1? That is by subtracting 1 from x axis and subtracting 1 from the y axis, right? For example, we have then 0 comma minus 1. That means we are keeping this particular x axis as the similar value, and we are subtracting minus 1 from the y axis to get this particular element, to reach this particular element. Okay, so like this we can reach all the elements in one hop. Okay, but what if the case is of, okay, so what if there is a case of two hoppings, right? So for example, if we take the similar 3 number. So from here, what are the two hops that I can do? One will go to 7, and then another one will go to 3. Okay, so similarly, all the integer values which are present here will come in my two hop, 1 2 3 4 10, and all these value boundary. Basically from 3, I can, whenever I hop two times in whichever direction, I will reach these elements. So if you sum up all these elements, they add up to 16 elements, right? So I will be having 16 indexes, and similarly we can achieve the same thing over here as well. So in 16, for example, we have minus 2 and minus 2. So we have 2 comma 2, and from here we need to reach 0 comma 0, right? That is the index value of 1, right? So how can we reach 0 comma 0? By subtracting 2 from both x axis and y axis, right? So this is what we will be doing in our program as well. So what we'll be doing is we'll be writing two function, both for one hop and two hop. And every time we am getting my query as one, I will perform this particular one hop operation. And if I'm getting my query as two, I'll be performing the two hop operation. We'll be going through the code so that you understand it better. All right, so this is the code we have. Okay, we have the answer vector, and I will be iterating through my queries, and we will go to every index and store the k value, r, and c. So k is basically having 1 or 0, that is which operation has to be performed. That is either one hop or either two hop, right? So if k is equal to 1, I will push back one hop function value to my answer, else I will push back two hop function value to my answer, right? So what are all the attributes that I'm passing? That is my n, m matrix, and rc. So rc here represents the ith and jth row and column, basically the current element which I'm having for that particular query, right? So for example, if we have two hop, we don't have to do anything. We have the same vector arrays that I have already explained here. Oh shit, yes. So we have that particular vectors, right? And what we need to do is we will have a sum variable, okay? And we will iterate through these 16 directions. At every index I will get a new row and a new column, right? So how will we get this new row and new column is by adding that ith and adding that x axis and y axis at that particular index, okay? For example, for the first value, I need, see, over here we have 2 comma 2, right? And we need to reach 0 comma 0. So we need to subtract 2 from both I and j. That is basically from both x axis and y axis, I need to subtract 2 in order to get 0 comma 0, right? So that is what we are doing. We will add that particular indexes, x value and y value, and we will get a new row and new column. So we have to check if that particular new row and new column is following the constraint, that is new row should not be greater than, or sorry, it should be greater than equal to 0, and it should be the less than the n, that is my number of rows that I can have. You know, obviously it cannot exceed my limits, the limits of size that we have. And if it is following all the constraints, we will just add up in our sum value and we return the sum, okay? And here also in one hop as well, we are doing the same thing. We will iterate through all the 8 directions that we have. We will get the new row and new column. If it is following all the constraints, we will sum it up, we'll keep it, store it in our sum, and return that particular sum. So I hope you're clear with this approach. Thank you.